Hello everyone, in this video I'm going to talk about Hangman Master. This is an artificial intelligence program that is created by using genetics algorithm. In this video I'm not going to really get into details, loops and for each in detail, how they work, things like that. In broader aspect, what each method is doing, what is application really doing, what is it trying to achieve, and how it achieves really. So let's dig in. So the alphabet is every single letter we have in the alphabet, words and letters being randomly created using by this string. Here we have the population size. Now population size is used as generation. One generation in this case has 20 population individuals in it. This could be 100 people in one generation, or could be 10. So this number really we are setting up to see how many individual is a good number for a given population in this application that we are working with. The solution is the word that we are trying to find using this application. So at first, application has no idea about what word we have when it generates the first population. Then it works towards getting the solution. Now, the main area has all the important things that this application is running. So let's check that out. Now list node we are creating here, this code creates the first population. So it creates the word, empty word, it creates every single letter and assigns this to a word, and then checks the fitness. Now fitness is how close is that word to the solution. If two letters are matching with the solution, then that word has a fitness point level of 2. So depending on how long is the word, if it is total 4 digits, the maximum fitness would be 4. If there are 6 letters in a word, then the total fitness could be 6. So this fitness checks how close the current word is, and here we are creating a node object and we are adding that to the population. Individual created here as a node object, and that's being added to the population. Now this goes as long as the population size. So whatever the population up there we added, it creates that many of individuals within that population. So here we are printing the very first population we created. This is fully randomly created population. Now we get into this while loop that is for each generation. For each generation that is being created, every single thing in this method gets done. So what we do is we choose two parents, parent 1 and parent 2. This is done through selection method. We send in the whole population inside the selection method and we choose one parent. Then we do the same, then we choose parent 2. Now let's quick look at the selection method. In the selection method, we are getting a whole population and we have a tournament. We select the size of selection for the tournament, dividing the whole population's amount of population we have by 4. So if the population size 100, then our tournament will be 25. So we create the tournament and we add randomly 1/4 people to the tournament from the population. And then we go through the tournament this time and we find the best within the tournament, the best individual in the tournament. So we randomly add people to the tournament and then we go through it and then we select the best in that randomly added tournament, and then we return that. So this is what the selection does. Really, it sends in 1/4 of the whole population, and then it finds the best, and then it returns that, and it sends again 1/4 of the whole population, it finds the best, and it returns that. So this is really aimed at finding the best out of randomly picked individuals. Here we have the child. The child is created by crossing over parent 1 and parent 2. So let's talk about crossover function. Crossover function accepts two words, parent 1 and parent 2. These are two string words. So what it does is it goes through every single letter in the word and then compares if parent 1, first letter of parent 1 is same as solution letter 1. If both letters match, then it adds parent 1 to the solution that it's going to submit. If then it goes to second letter. Is the second letter of the parent 1 is the same? It is the same. Okay, add that to the word string that we are going to submit. Now, if it is not the same, then it gets the letter from parent 2, hoping that parent 2 has the correct letter for that location. If it doesn't, it's fine, but there is chance that it might. So this gives some variety, as well as this avoids changing letters in the word that is not correct. So we are avoiding getting a word from parent 1, getting letters from parent 1 that are not correct into the solution, into the word that we are going to submit here. So that's what we are really trying to achieve there. So let's get back to the crossover. So after crossover, out of these two parents, we get one single child. That child replaces one word, one person in the population, one individual in the population. So here we are changing that whatever the number individual we are working with, the word of that child individual, and then the fitness of that individual. So we have to recalculate the fitness because fitness may change. And here we are checking if the child is equal to solution. So if the word that we came up with here is equal to solution, we don't need to continue anymore. We can just cut the application from generating more generations. We can just say we found the solution. This is the solution. This is the location we are at. So this is what that does. Here is the mutation. So every fourth generation, every generation that is divisible by 4, we run mutation. What this really does is that this helps us not to get stuck sometimes, because what happens with genetics algorithm a lot of the times is that it gets stuck because it invests into wrong individual. It thinks one individual has 3 points, and then points coming from RTL letters, and the solution has 10 digits, so it just creates a word called RTL. That is definitely not the solution. Well, there are 3 letters that are matching, but that is definitely not going to be the solution. So this helps us get out of that kind of getting stuck once we invest in wrong individual situations. So let's look at the mutation. What the mutation really is doing here, for the broader aspect, is that it checks every single word, it converts into char array, and it checks every single letter in that array with the solution. If the letter is correct, it's great. If it's not correct, it generates a new letter from scratch and it changes that letter. So we are not getting stuck at any wrongly invested individual. So that's what we are doing in this mutation pretty much. So after the mutation check, we are checking if generation loop is false. If the loop is false, that means we found a solution. If generation is true, all we are doing is pretty much printing the population and increasing the generation number by 1 and then looping again. If the generation loop is false, here we enter and then we say, and then we print up until to the location that we find the solution, and then we lastly print wherever we find the solution. Thank you for listening. So in this video I'm going to talk about how this application really runs. I previously talked about how it really worked within the code. Let's see it run. Okay, so here we found the answer in a 13th population. Here if you look at the first generation, it's pretty much randomly created letters. Now in the first generation, to this word that we randomly generated had a fitness level of 2, and that is because happiness, this H and I are correct. So that means 2 letters are correct out of all of the letters. That means this fitness is 2, and here fitness is 0 is because nothing is correct, and this is fitness is 1 because 1 letter is correct. So this is really created randomized, and this is where the really magic gets in. These we create based on the high scoring parents. So here I can really show when it happens that one individual takes over a certain part of the population, and it has some here. This individual took 2 slightly, so this really mutation helps in these kind of situations. So because this has fitness level 4 and these have fitness level 1 and 2, application really invests in that, and we can see in generation 3 it's all pretty much the similar word. But since we have every 4th generation mutation, it gets out of that, and we can see that happening here. This word has fitness level 4, but it's not the same, so it's different. It was changed, so it got out. Then some other individual dominated again, and it clearly dominates some part of it. These 2 individuals are dominating. They have 6 fitness level, and then there's 7 getting in, with the people with 8 and 7 fitness levels taking over the generation, and towards the end here just fitness level 8 took over this very same. It's very, very close to the solution, but it is not the solution, so we need to get out of this. And once see, these all, they're the same because the same individual took over the whole population. And here when it came to 12th, application ran again that mutation, and in that mutation it changed some of these letters. See, it's HJP, HTP, so it changed this letter in this case. In this case, this letter. So it got out of that situation that it was stuck in, and it found the answer by just randomly assigning that letter to that spot. And if you thank you for watching.